Assalamu alaikum student. Welcome back to another lecture, that is lecture number 2, Metric Class Physics. Today's learning outcomes. After completion of this lecture, students will be able to number 1. Prove that the motion of a mass spring system is simple harmonic motion. Number 2. Also able to prove that the motion of a simple pendulum is simple harmonic motion. This is Mohammad Shahrukh Ali, and you can view my lecture on MSc Group of Education. To prove that the motion of the object is simple harmonic motion, we have to go through our previous lecture, where we come to know that if the object or the motion is satisfying the following condition, then it is executing simple harmonic motion. These conditions are: number 1, a body should execute vibratory motion. Number 2, its acceleration should be directed toward mean position. And number 3, the magnitude of acceleration should be directly proportional to its displacement. Now to prove that the mass spring system is executing simple harmonic motion, let us suppose the following. Consider a mass m attached to the end of a spring whose other end is fixed. The whole system is placed on a smooth horizontal frictionless surface. If the mass m is displaced from its equilibrium position O, it will start to vibrate to and fro about its mean position due to elastic restoring force, which is acting towards mean position. Now this paragraph means a lot because it has proven two conditions for simple harmonic motion. Don't you remember that the vibration was the first condition to have simple harmonic motion and our object is vibrating? Now for the second one, that the acceleration is directed toward mean position, I am going to prove that the force is directed toward mean position. Whenever you are going to take away the mass m from its resting position or say equilibrium position, the force will always start to act on a mass m that pulls the object towards its equilibrium position. This force is acting towards mean position, and we know that the force is directly proportional to acceleration, so its acceleration will also be pointing toward mean position. This means that the elastic restoring force is actually acting towards mean position, due to which its acceleration is also acting towards mean position. Now here we satisfying the second condition for simple harmonic motion. Now for the third one. Third one is the mathematical form, that we have to prove acceleration A is directly proportional to displacement x, and the negative. There should be a negative sign which shows that its acceleration is directed toward mean position. Now the elastic restoring force of a spring can be given by Hooke's law that we have already studied in class 9. According to Hooke's law, F is equal to minus kx. Let's say this is our first equation, where k is the spring constant and its value depends upon the nature of spring. Let's suppose we have two springs. First one is a soft spring and the other one is a hard spring. If you are going to displace the hard spring 1 centimeter and similarly the soft spring at 1 centimeter, both will exert different forces. The soft spring will exert less force and the hard spring will exert larger force. This is not because of the displacement. The displacement for both the spring is 1 centimeter. Then why the hard spring is applying greater force comparatively with the soft spring. This is due to the stiffness of the spring. Generally, you have to note down this. The value of K is larger for a hard spring and smaller for a soft spring. So that is why the large spring is exerting greater force on you when you are displacing it 1 centimeter. On the other hand, the soft spring is not doing that. So now, if you remember Newton's second law of motion that we have already studied in class 9, according to Newton's second law, F is equal to ma. Now our first equation also contains force F. We can replace this force by ma, and our equation 1 become ma is equal to minus kx. Now taking mass to the other side of the equation, it's multiplying on the left hand side and definitely it will be dividing at the right hand side. Our equation becomes acceleration is equal to minus k upon m into x. Here k and m are constant. We know very well that k is a spring constant, and once we have taken our spring, we are not going to change. And similarly, if the mass m attached to the end of spring, we are not going to change the mass as well. The only thing is going to change is acceleration or displacement. These two physical quantities are changing during the motion because displacement is increasing or decreasing, and so on the acceleration due to the force increasing or decreasing. But k and m, spring constant and the mass remains constant. Hence, we can replace k upon m with the constant, and this is pretty much common in the mathematics. Whenever there is a proportionality sign, we remove the proportionality sign with the help of constant and equals to sign. Now if I am going to remove this equals to sign and a constant, then I have to put directly proportional sign next to it. So now you can say the acceleration is directly proportional to negative of displacement. The negative sign is due to the fact that the acceleration is directed toward mean position. It is the reaction for the action. If you are stretching the spring, then the spring is also exert force on you. This force will be similar. If you are going to spring for a longer distance, it will exert a larger force, or if you stretch a spring for a smaller distance, it will exert a less force. This is just because that this is the action for the this is the reaction for the action. Now let's suppose if I am stretching the spring and it is exerting the force on me, then the force I am exerting on a spring is opposite to the direction of which the spring is exerting on me. So that is why we use the negative sign in the equation. And since the acceleration is directly proportional to its displacement and directed towards mean position, the mass spring system executes simple harmonic motion. We have successfully proven that our mass spring system is executing simple harmonic motion. Here, your first question of today's lecture completed. Now you have to copy this question starting from here, that you also have to draw a diagram